Next up on the docket is multiplying polynomials. If you've practiced your exponent rules and you've practiced combining like terms, this lesson should come very naturally to you. If not, you should go back and practice those now before moving on to this lesson. So when you're multiplying polynomials, we're just combining the rules that we've already learned. When you multiply polynomials, for example, these all are monomials, meaning they have one term. We multiply the coefficients. 3 times 4 makes 12. X to the fourth times x squared, we saw 2 lessons ago. You add exponents when you multiply things with like bases, would make x to the sixth. Here, negative 4 times 2 is negative 8. C to the fifth times c squared makes c to the seventh. We add those exponents. D times d to the third makes d to the fourth. Add those exponents. And e. 1/3 times 3/4 makes 1/4. A to the fourth. B cubed times b to the 7 makes b to the 10. Again, we add those exponents. I've got a couple here for you to try, very similar to those last. And I'll reveal my answers. If you ever need to pause, feel free to pause the video to try these yourself. So negative 5 times 6 makes 30. Y to the fourth. 7 times negative 2 makes negative 14. X to the fifth, y to the fifth. And 2/5 times 15 over 4 makes 3/2. W to the ninth, z to the third. When you're multiplying a monomial by something else, a multiple term polynomial, you have to do what's called distributing. This is the distributive property we talked about in lesson 1 of multiplication over addition or subtraction. So notice I have a 2t outside the parentheses, and I want to multiply it by this entire parentheses. What I have to do is distribute the 2t into both items. So 2t times 4t makes 8t squared. 2t times negative 3 makes negative 6t. And then if you can combine like terms, you should. You should always check for like terms when you get to the end to make sure there's nothing else that you could simplify. The same thing on this bottom one. I'm multiplying negative 3a squared to everything in that parentheses. So first, negative 3a squared times negative 4a is 12a to the fourth. Negative 3a times 2a is negative 6a to the third. Negative 3a times negative 1/3 is positive 1a squared. Look for like terms. I don't have any like terms I can combine, and so I'm done. Here's another couple for you to try. Again, pause the video, try them yourself. Here are my answers. All right, when you're multiplying polynomials, a polynomial by a polynomial, the difference in these only had one item multiplied by maybe multiple items. Here we have multiple items multiplied by multiple items. What we have to do is make sure that we make every combination possible. And so we're going to, with 2 binomials, what we're going to do is use the FOIL method or distribution method. I would prefer to just call it distribution and use that distribution rainbow. So here, I need to multiply the c by everything over here. And I also need to multiply the negative 7 by everything over here. So let's just start with the c. We're going to make every combination we can. C times c makes c squared. C times 2 makes 2c. Negative 7 now. Negative 7 times c makes negative 7c. Negative 7 times 2 makes negative 14. Check for like terms. Notice that these two in the middle both have a c. So I'll have c squared minus 5c minus 14. When you combine those like terms, last lesson we learned that when you combine like terms, we just have more or less of the same type of thing. We have 2c's minus 7c's, we get negative 5 of the same c. Same thing on this bottom one. I need to multiply the x by everything, followed by multiplying the 2 by everything. So first, x times x is x squared. X times 8 is 8x. 2 times x is 2x. And 2 times 8 is 16. Always look for like terms, and look at these middle 2 terms. They both have just an x, so I can combine those. X squared plus 10x plus 16. 8x and 2x, we have 10 x's. Multiplying, it's the same type of deal here. We're trying to multiply the y by every term, right? Every separate item. And then we'll multiply the negative 2 by every term. All right, let's try that. Y times 3y squared is 3y to the third. Y times y is y squared. Y times negative 5 is negative 5y. This is a negative 2 that I'm multiplying by 3y. It is negative 6y squared. Negative 2 times y, negative 2y. And negative 2 times negative 5 is a positive 10. Let's look for like terms, and I'm going to do this in descending order to make my life easier in the next step. The highest exponent I have is y to the third, and I only have one item, one term with y to the third, so it's going to remain the same. I don't have anything that it can combine with. Next up is y squareds. I have 1y squared minus 6y squared makes negative 5y squared. Next is my regular y terms. I have negative 5y minus 2y makes negative 7y. And then finally, I have just this numeric term out here. There's no other regular numbers to combine it with, and so this is my final answer. I did the same thing in the next example. I distributed the 2y to everything, then distributed the 4 to everything, and then combined all the like terms. If you ever have a number out front, just a regular number, we're just going to have to do this in pieces, okay? So what we're going to do is first, we're going to distribute the 2 to everything. So that would be 20x plus 6y. Then we'll distribute that first parentheses to the second parentheses. So notice when I distributed the 2, I don't have to distribute it to both parentheses. I just have to do it to the first. I'm just multiplying these two items. Then when I get, I'm going to multiply by the second 2. So 20x times 2x is 40x squared. 20x times negative 4y is negative 80xy. 6y times 2x is 12xy. And 6y times negative 4y, I'm running out of space here, is negative 24y squared. And then we'll look for like terms. Notice these middle two terms both have an xy, so I can combine those. That makes 40x squared minus 68xy minus 24y squared. That's my final answer after combining like terms. Same on this next example. We'll have to distribute the 3 in first. This is what that looks like. And then we can do our distribution from the first parentheses to the second parentheses. And then we can combine like terms. All right, multiplying conjugates. This word conjugates means that we have the same items in both parentheses. They're just separated by a different sign. So notice this has an x and a 9. This has an x and a 9. The only difference in the two parentheses is one has a minus and one has a plus. Those are conjugates. The same thing here, a half p, a 6, 6. The only difference is the plus and the minus. These are conjugates. The word conjugates means we have the same exact items, but with a different sign between them. There is something special that happens when we multiply conjugates. We're going to use the same strategy, but the answer is going to look a little different. So x times x, x times x, I'm sorry, my line is x squared. X times 9 is 9x. Negative 9 times x, this is a negative 9 times x. And negative 9 times 9. And now let's combine our like terms. Negative 9x plus 9x, positive 9x minus 9x is no x's left. And so our middle terms actually cancel out there. When you multiply conjugates, that should happen every time. So let's try it here and see if the same thing happens. A half p times a half p makes 1/4 p squared. A half p times negative 6 makes negative 3p. Now let's multiply the 6. 6 times a half p makes positive 3p. And 6 times negative 6 makes negative 36. Look at these two middle terms. Notice that they're the same but opposite. Those two will cancel out, and we'll have 1/4 p squared minus 36. These two just add to 0 is what happens. When you multiply conjugates, like I said, that should happen every time. Here's a couple more for you to try. This is what it looks like when the first one's distributed. Notice the middle terms are the same but opposite, and so those will cancel out. Same deal on the bottom. Distribute. We've got a positive 8x and a negative 8x that will cancel out to 0. All right, when you're squaring binomials, you notice this square sign here. We cannot just square the first one and square the second one. That's a very common mistake, one of the most common mistakes in algebra. What we have to do is, if we have any item squared, here we can make a little note up here. If I had 9 squared, same thing as 9 times 9. If I had 5 squared, same thing as 5 times 5. If I have x squared, same thing as x times x. If I have 3w minus 4 squared, that's the same thing as 3w minus 4 times 3w minus 4. These are not conjugates. They're the same exact item twice, right? If we square something, we multiply the same item by itself. And now we'll distribute. 3w times 3w is 9w squared. 3w times negative 4 is negative 12w. We get another negative 12w and a positive 16. Combine those two like terms. We get 9w squared minus 24w plus 16. Let's try this one more time. 5x plus 2, all squared, is the same thing as 5x squared plus 2 times 5x squared plus 2. Anytime you have a polynomial squared, you have to write it out twice. 5x squared times 5x squared is 25x to the 4th. 5x squared times 2 is 10x squared. 2 times 5x squared is 10x squared. And 2 times 2 is 4. Those two middle terms add to 20x squared. I'm sorry, this item over here is x to the 4th, isn't it? Here, let me erase that and fix it for you. I've got the last two examples for you to try here. 2x plus 3 squared is the same thing as writing the same thing out twice. Distribute, combine like terms. And the same thing on the second one. 5c squared minus 6 squared is the same thing as that thing multiplied by itself. Distribute, and combine like terms. Make sure you've got a handle on this, because the next thing we're going to do is a little more difficult. It's going to be dividing polynomials.